Thanks for having me on this operations track, and very happy to share my thoughts to the audience, to the people joining us today. So let me see if I can share my screen again. Okay. Hopefully you guys can see my screen, and again, very happy to be today on this conversation, which of course, as John introduced, right, is about AI, which there's been already some of that on the event, and you're probably hearing about this constantly in the industry. But I would like to take this conversation today a little bit more personal, right? I don't want to talk to you about this as you being part of an organization. I would like you to listen to this as being a network professional, as a network engineer, and how this might impact you also in your next steps, right? From a professional point of view or personal point of view. Why are we talking about AI so much these days? Well, in a good part, because our industry has set a very ambitious goal. We've been talking about this for a number of years, but now it's becoming more and more important than ever. How do we get to the autonomous network? We had yesterday a few conversations around the overall idea of the autonomous network and what it means, and several forums like TM Forum, Etsy, ITUT, and others are really pushing towards make this ambition real, in very similar definitions and very similar approaches, but definitely the forces are aligning towards how do we make this real in our industry, and why this is happening right now. I mean, why so much emphasis in making the autonomous network a reality? Well, one way to look at this is because we all are in the middle of a perfect storm. And somehow that perfect storm is the confluence of a few factors that are feeding, each other, right? First of all, the networks are more complex than ever, and we could, view this from multiple angles, whether it's a scale, whether it's, number of devices, services, etc. So the complexity is higher than ever. But at the same time, the expectation from your end users, right, are higher than ever about, the performance of that network, right? Measuring there's no performance or reliability, response times, anything that can be used to measure the behavior, the performance of that network, the users expect more because, for practical purposes, our lives depend on the network these days, right? And then, on top of that, the resources that you all have to manage these infrastructures are more limited than ever and probably even trending down. So this results into an almost impossible situation, this sort of perfect storm that we and you need to navigate through. How do we navigate through this? Well, the answer is basically what we all do these days, especially in this community, which is automation. But it's taking automation to an unprecedented scale. That unprecedented scale is what we call the autonomous network, right? And is it just about doing more of what we have been doing, like running more workflows or running more provisioning processes and so on? Well, definitely we have to do more of that. But it also means starting to do things that we haven't done before, right? That's what will take us really there. And what is it that is missing that we need to start addressing? When we look at any process in our life cycle of the network, right? There are decisions and there are actions that are executed associated to those decisions, right? From a network automation perspective, we've had primarily a focus on automating actions. We have built tools for that, built orchestration tools, workflow engines, provisioning tools. We've been talking about all those tools these days and what is possible. But the main focus of those is on how do we automate actions. The decisions that surround those actions are still highly dependent on people, right? They depend on knowledge. They depend on reasoning, right? And of course, they also depend on data and algorithms. But if we need to scale automation as a whole, and we continue focusing on automating actions, the decisions associated will become the bottleneck because the humans are the bottleneck in that context. Can we scale the human component of it? We cannot. Definitely, we cannot multiply the amount of people that we have managing our operating networks. That's just not really feasible. So what can we do? Then we need to find a better way. We need to find a different way in which we can use technology to help us make more decisions, better decisions, and faster decisions. And this is where AI will help us. So back to what I was mentioning earlier, why are we talking about AI now if this is a network automation community for the most part? It's because AI is just the natural enabler for the next phase, for the next era of network automation, where we embrace not only automating actions, but also automating decisions, right? And as network automation engineers, we need to start embracing that part. Of course, there are certain foundational building blocks that need to be there to be able to start addressing that decision component, the decision layer. And those foundational building blocks are those that enable us to get the proper insights and those that enable us to automate the actions, as I was saying. So it is about insights, decisions, and actions. And the foundational building blocks, we have already, laid them out with our Crosswork automation portfolio that enables us to provision services, to automate workflows, to analyze and visualize data and provide assurance for services. So all this cycle, it's already there. That's the foundational building block. Now is how do we extend this foundational building block with AI to be able to get there, to be able to get to the autonomous network? Where does AI really help in this context? On one hand, AI will help us get better operational insights. So transform data, raw data from the network into something that is more useful. And there are multiple algorithms and multiple use cases. We'll see some examples. Once we have the insight, what we want to do is to make a decision with that insight, right? So AI can help us also to accelerate and automate those decision processes, precisely the bottleneck that I was referring earlier. But then once you have a decision, you really want to transform that decision into an action. You want to enforce the consequences of that decision. And you need, tools to transform those decisions into actions that will be able to automate those actions. There is also opportunities where AI can help us make it easier to automate those actions. So as you can see, AI helps us in almost the entire process in one way or another. If we double click a bit on the insights part, right? I mean, it is clear, and we all know that you can't improve what you can't see. And that starts by being able to collect the right data from the specific sources that generate. And I will not go into the details, but we have all of different options in our portfolio and technologies to get the right data and the right granularity. But of course, that data is always contextualized in different domains and require specialized analysis to produce something meaningful. And that's the reason why we have domain-specific tools and systems that will allow us to analyze that data and produce the relevant insights in the context where they are produced and consumed, right? So some of the examples of our tools in our portfolio, right, will help us analyze and contextualize that data where they belong to. But then now, on top of that, especially for those cases where we need to start having a multi-domain, visibility and analysis, we have now that top layer framework that will allow us to merge, to consolidate data coming from different domains, both network-related domains or non-network-related data that might still need to be, brought together, right? So these are the key building blocks that will, facilitate building those operational insights that are relevant and necessary to get through this cycle. But what type of insights do we need, right? Traditionally, we've been focusing a lot in building reactive insights, those that help identify that something is going on and be able to fix it quickly, right? That's definitely useful. That means the problem already happened, right? Algorithms and data are available for us to take this further and be able to take a more preventive or proactive approach, build insights that will allow us to identify maybe that something is about to happen, or that there is a higher possibility that something will happen if a certain factor happens, right? Or that certain events are being greatly influenced by certain type of conditions, because if all that happens, then we can maybe reduce the occurrence of those network incidents. So that's, the very next step that we can take. And taking this further, we can use data and algorithms to be more prescriptive, to build knowledge that will help us, more, adequately to the specific context, operate, configure, and evolve the network infrastructures based on the knowledge generated with data. So there's a number of examples on this slide. I will not go into the details. We can, I'm happy to go through more and, double click on any of them if you guys are interested at any point in time. But all these are areas and use cases that we are working on, and we have prototypes. But I want to show you one just to illustrate an example of the potential that analyzing data brings us in the context of network operation. Right? Configuration drifts or configuration anomalies, it's a constant challenge, right, for any network operational context, especially for those cases where, there's still the possibility to change the configuration manually, right? We have been dealing with this type of challenge with templates, with golden templates that you have to define and then, run against, those configurations. But there are challenges as well associated to creating, maintaining, and applying those templates. So machine learning gives us the possibility to take a complementary and alternative approach, which I'll quickly describe, right? And of course, the context, as I said, is that there's still a lot of people and a lot of contexts where changing the configuration through the CLI, it's still a possibility that it's allowed, that is permitted. And if that happens, that means there is a possibility to make mistakes. So we want to identify, hey, is there any anomaly? Is there any deviation in a specific configuration from what it should be? But we want to do it in a way that the system somehow can automatically understand what is the right or wrong configuration in a specific context, right? Not because I tell explicitly via certain templates, but because the system might learn automatically that knowledge from the actual configurations. And this is an example that we have been working on. So you can train actually a neural network model, what we call a configuration language model, with the actual configurations, right, from a network, whether it's Cisco configurations or any other vendor configuration. It's really agnostic from that perspective, and be able to detect anomalies in case they happen, in case there is a configuration that doesn't fit into what the model has learned. And in doing so, we can actually detect both cases where there is something misconfigured that shouldn't be there, like maybe a wrong MTU, or whether there is something missing in the configuration that the system thinks it should be there, or whether there is something extra that shouldn't be there as per, the knowledge that the model has learned. So again, this is just a quick example of the possibilities that we have by analyzing different types of data from the network, in this case, configurations, and turning that into relevant insights that allow us to make decisions. But now let's jump into the part that I think now is really the one that has the most potential, which is how do we use AI to accelerate decision processes? The insight part is relevant because once you have the right insight, then it's easier to make the decision, but still someone has to analyze the data from different sources and make that decision. So how can we really accelerate and facilitate that? There is a very interesting phenomenon going on, not in our industry, worldwide, across all industries, which is this idea of the AI agents or autonomous agents. And this is really revolutionizing industries, many of them, right? These are just examples, but there are so many these days, right? Examples from a data operations perspective or from a sales operation perspective, right? Autonomous agents as entities that can make decisions and help us take automation of different processes to a next level. And when we start thinking on the analogies, right, to our industry, the potential is, significant. What is an autonomous agent in practice? Well, you are all familiar for sure on what a language model is, what an LLM is. An LLM is basically mathematical functions. It has no life or no proactivity. You just introduce something that we call a prompt and you get an output, you get an answer. That's all it does, right? So it doesn't have by itself the ability to solve complex problems because it's static, right? It's passive. But we can use a language model to build software systems that actually have, a more active behavior. You can use a language model within a software system as if it was the brain of a system that can self-plan that can, execute on a plan, that can run certain functions and action that is enabled to do, right? That can even self-critique what it is doing, or whether what it is doing is right or not. And it has short-term and long-term memory. The consequence of this combined is that these are goal-seeking entities. You can request an agent a complex problem, and the agent will solve it. You don't need to tell how to solve it. It will figure out automatically the plan to solve it based on the knowledge that this language model has and based on the context that you provide. But ultimately, it self-plans and it can autonomously execute. So we start seeing, oh, one entity that can autonomously execute complex problems. This sounds very interesting for our autonomous networking vision. And even more, when we think that we can combine multiple of these entities, multiple of these agents together, right, in multi-agent architectures that can solve even more complex problems. Right? So this is revolutionizing, whole industries. And when we think about this, this is going to impact us, and it's going to impact you as a network engineer. So you need to start not only being aware, but also being very familiar with how this technology works and what's the potential of this. A few months back, early this year, on this NVIDIA event, Jensen Huang, the NVIDIA CEO, was talking about his view of what is the future of software development, right? Software development as an activity, as an industry. And he literally described it like this, right? You will assemble a team of AIs, which means agents in this context. One of those agents will take the mission that you want, your goal, and will break it down into an execution plan, right? And then each of those steps from that execution plan will be handed off to specialized AIs, specialized agents, to effectively go and execute them. This was, early this year, it was described as the future of software development. Well, it's already the present of software development. There are already systems that are building software using this type of approach. And, in many cases, the performance and the results are really impressive. There's still a lot to improve, but we are seeing that future is already now, right? So if we take that to our scenario, to a network scenario where we have a network engineer dealing with multiple systems, right? Automation tools, AI ops, inventories, and all sorts of monitoring tools on top of the network infrastructure, whether it's network or cloud or both, right? Whenever that network engineer has a request from someone or needs to deal with a situation, these are all the systems that that person needs to interact with, that you need to interact with, and you need to know how to do that. And each of those interactions is time and cost, of course. This can evolve over time to that alternative scenario where now intelligent agents, autonomous agents, help us accomplish those goals, right? The agents know how to interact, how to deal with all these different systems, and can help us automate processes that otherwise will require us, going and finding all that information directly, including potentially diagnostics and troubleshooting. So as we move forward in this journey with AI agents, the decision processes will be accelerated by the agents that will help us obtain the information we need. And probably initially we will make the decision that we need to make just faster, just by the fact that the data that we needed to make that decision came more reliably and faster using agents. But in a subsequent step, those agents will collaborate with each other to provide a more curated view that will help us actually even accelerate further the decision process. So this is likely going to be the future of how we will operate moving forward our infrastructures, which logically we could represent in some way like this, right? We have all, maybe this, and it's not super exhaustive, but these are maybe the most significant functions that we have in our operational ecosystem to deal with our network, right? We have, or maybe assurance stack with real-time analytics or incident management tools or workflow automation tools or controllers. And all these systems have flows of data either up, towards the human layer to get the data and interpret, and down as the flows of, intent push or operational state change. But now there's going to be a new layer coming up which is that autonomous AI layer that sits between the humans and all the systems, and will help us, will help abstracting the complexity of dealing with all the systems, because the agents will know how to do that and will help us execute complex tasks in a way that we can really truly delegate some of those tasks to the agent. And over time, more and more of those closed loops that we also always have the ambition to create will be closed at the agent layer and not so much at the human layer in the future, helping us, approaching those TM forum level 4 or level 5 levels of autonomy, which are, or let's say, industry ambition. Some examples, and we've been working on this technology for some time, and we see how this is progressing both from a perspective of the logic to build the agents and from a perspective of the language models that support these agents. But let's take the example of an environment where we have provided connectivity assurance, and we have an agent that helps us get more directly and quickly responses to certain questions that we might have. Again, this is just an example, but let's say we have this situation where we got an alert associated with a specific object, with a specific entity that we are monitoring. And we need to know if over the past 24 hours on a certain metric associated to that object, there's been any anomaly, right? And have a view of why those values are anomalous. We never told the agent how to do any of this analysis. We just have enabled the agent to know how to call a specific REST API that gives you the ability to query a certain metric, or any metric for that matter, and the agent can query whatever metric is asked to eventually. But in this process, when I made this request to the agent built a plan autonomously about how to respond to this question, got the metrics from the system, analyzed the metrics by itself, and came up with a way, which in this case is the C-score, which is just a statistical measure to identify if there are anomalies on any of those specific values. So I never told the agent how to do any of this. The agent figured out based on the context and the type of request that I gave and the tools and functions that I enabled the agent with. Similarly, we can use agents potentially for more complex problems, more distributed problems, like a troubleshooting of network issues. In this example being, hey, a BGP session is down, why it is down, right? So we can have agents working, collaboratively, diagnostic agents that is focused on the diagnostic plan, on the troubleshooting plan, and search agents that are focused or enabled to actually go find the information that the diagnostic agent need for any of those steps in the troubleshooting plan. So collaboratively, they can actually go and respond to the questions that we have, requested. In this case, the reason why the BGP session is failing, right? So this is not production deployable yet. It will probably not be, a use case like this, network troubleshooting, network-wide troubleshooting, for the next months or year, but it's really around the corner, the time that we will be able to get this type of use case to production quality. As per TM Forum, a few months back, they released what they call the, blueprint to make level 4 autonomy real. And in that blueprint, they really highlighted the role that autonomous agents will play in getting there, in getting to the level 4 autonomy, both single agent use cases as well as multi-agent in a subsequent phase. So this is really, going to become the concept of agents and multi-agents. It's going to become a really key component as in the way we operate and we manage networks moving forward. So I think it's important that we all get familiar with it. And ultimately, what is it that we are doing, right? When we are addressing, operational problems with this type of techniques? Well, we are actually unlocking the long tail. If we sort of visualize most of the activities that we do in the context of network automation or network operation, there is always this long tail shape where, for the things that are more frequent, traditionally, we have created rules. We have created templates. We create, different types of artifacts that help us deal with those situations that are more frequent or maybe we consider more important. And those are well covered. But what about the rest? What about the long tail? This is where we spend most of our time because those are not automated, those are not managed. So we have to spend our time troubleshooting the issues that are less frequent, correlating the log messages or the events that are less frequent, or dealing with those situations that we haven't automated yet. Autonomous agents and basically the opportunities that AI bring basically will help us address that part of the long tail that otherwise today, most of the time, it's uncovered. So when we think about the future of network automation, and think of this again based on your personal, the impact that will have in you personally, right? Today, we encode our knowledge somehow in rules, right? We create one rule or one rule set for every use case that we want to automate, whether it's a closed loop use case or any other type, right? And this is fine to ascertain a scope, to ascertain limit, but we cannot go beyond this level 2, level 3 of levels of autonomy, right? Because it's impossible to manage so many different rules and templates. This is going to evolve to a scenario where agents will take that additional role, where we will teach agents skills that will allow the agents to interact with all these systems, right? And given the right context and the right goal, it's the agents that will actually enable those use cases, those closed use cases based on what they know and the context of people. And this is what will take us from level 2, level 3 to level 4, level 5. And what's in it for you, right? What's in it for you personally? I think as a network engineer, you have to understand AI ML to at least the point to recognize where it is applicable, where you can actually identify the opportunities, right? And where you can have a critical mind, not to necessarily believe blindly what we vendors maybe tell you, because there will be cases where you might receive messages or solutions that are actually not realistic or not really doable, and you need to have the critical mind to understand what's real and what's not, what is the art of the possible. So I think for you as a professional, as a network engineer, you have the opportunity to expand, to move a little bit towards that gap between networking and data science. Right? The goal is not really that you should really be a master in data science, right? That's not really necessarily maybe it's not even a good idea, right? For sure, if you want to, do it. But I think expanding your skills to have a critical mind and identify opportunities will make you a better professional. But also as an automation engineer, you've seen the new arena of automation are the decisions. There's going to be new entities to manage, to create, and to deal with, which are the autonomous agents. They're going to be based on language models, and they're going to be, based on algorithms that will enable take, more advanced decisions. You have to be an active participant on this process, right? Because that's the natural evolution of network automation. So I hope you've seen over, the past 30 minutes or so that, when we talk about AI in this context and when we talk about autonomous network, it's not just this hot topic of the month. It's just the business, imperative on how do we navigate through the perfect storm. And you are in the middle of that perfect storm as well as a professional. So I believe it's important that you guys, get yourself more familiar with these technologies and start applying where it makes sense. So that's pretty much what I wanted to share today with you guys, and happy to take any question later.
Javier, that was great. I mean, I got a bunch of questions myself, and we're getting some from the audience. We're not going to have a lot of time here for a lot of questions, but
yeah,
I guess one question from the audience is and you had some examples in there, but a lot of the service providers already have automated actions, and this is kind of I think what you just touched on at the very end of your session. You have automated actions, but they're not they're not at the decision stage yet. So is there a specific where would you suggest these guys get started? And certainly, I think it's already in some of our products today where there might be a recommendation that's spit out, and then it's up to a human to decide to either, execute on a recommendation or not. And once they get to the point where they're just, hitting the button, yes, 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 I think that's the stage where they're, comfortable enough to make it automatic. But is there a use case or biggest bang for the buck spot where they should begin to look to do some of the experimenting that you just went through?
Yeah. Yeah, I mean, definitely, as you say, right? I mean, even in many cases, we might not even trust in automation, as we know it today, right? Sometimes people are still reluctant to automate. So, even more to automate a decision or to let a system take a decision. So in that sense, I think we need to go step by step. We need to build that trust progressively. And there are definitely use cases that are, like facilitating making complex questions from the network, getting insights, right? Or getting, ad hoc reports where you have a complex query, a complex, data that you need from the network, and you can let the system decide how to give you that information, right? I think these are the main type of use cases, like read-only, if you will, that we need to start to basically build that trust. And then, of course, any use case that is associated to making a decision that results into an action back with the network, make sure that we have human in the loop so that we can progressively build that trust. In parallel, technology is going to improve so that it will help us also increase the quality, the accuracy, right? The success rates of all these decisions so that we can also measure them and provide you transparency in that process. So I think collectively, we will need to make different steps to make sure that we get to a point where we trust enough in those decisions. But I think read-only use cases like queries, reports, etc., are a good place to start.
Yeah. And I know we're a little over here now, but just the art of the possible here, meaning segment routing technologies, SRMPLS and SRv6, have the ability to really provide surgical routing, path forwarding for different types of traffic. So, I can see a lot of use cases where kind of proactively, kind of like you said, not reactive, but proactively, um, that the network could move traffic before, congestion events happen, due to, historic data. Uh, in fact, there was one customer who highlighted that, whenever they had a transport failure, they could see that the optical power amplifiers were degrading for months. So there's plenty of things we
Exactly.
can begin to do that I can't wait to see what happens in the next couple of years.